fourth wire tapped to the grounding of the secondary star-connected winding in a 480-volt Y system is considered a neutral wire. This is because it carries current during unbalanced loads, providing a return path for the neutral current. There would be a code violation if you connect the fourth wire, the neutral, to one of the poles of a 4-pole automatic transfer switch. The National Electrical Code requires that the neutral wire be isolated from the equipment grounding system. In an automatic transfer switch, the neutral wire can become energized during a generator transfer, potentially creating a shock hazard or equipment damage. To avoid a code violation, you should use a 3-pole automatic transfer switch with a 480-volt load. The fourth wire, the neutral, should not be connected to the automatic transfer switch. Instead, it should be bonded to the ground busbar in each panel board through a separate neutral bonding jumper. Connecting the fourth wire to the automatic transfer switch could have the following consequences. Firstly, shock hazard. During a generator transfer, the neutral wire could become energized, creating a path to ground through the automatic transfer switch and potentially shocking personnel. Secondly, equipment damage. The energized neutral wire could cause damage to electrical equipment connected to the loads. This configuration would not meet the National Electrical Code requirements for isolating the neutral wire from the equipment grounding system. When dealing with electrical systems, especially those involving transfer switches and grounding, it's crucial to adhere to the National Electrical Code and best practices to ensure safety and prevent equipment damage. The neutral wire in a Y-connected system plays a vital role in carrying unbalanced current back to the source. Connecting it improperly in a transfer switch setup can create hazardous conditions. Let's delve deeper into the specifics of Y-connected systems, grounding, and transfer switch configurations to understand the potential issues and how to avoid them. In a Y-connected system, the transformer's secondary windings are connected in a star configuration with a common point called the neutral. This neutral point is typically grounded to provide a reference point for voltage and to facilitate the flow of fault current in the event of a ground fault. The voltage between any two phase conductors is 480 volts in this system, while the voltage between any phase conductor and the neutral is 277 volts. This is where the issue arises. While your plant may not have a specific use for 277 volt loads, the neutral wire is still essential for balancing the load on the 480 volt circuit. If the loads on the three phases are not perfectly balanced, current will flow through the neutral wire to compensate for the imbalance. Now, let's consider the role of the equipment grounding system. The equipment grounding system is a network of conductive pathways designed to provide a low impedance path for fault current to return to the source. This path helps to quickly trip a circuit breaker or fuse in the event of a ground fault, minimizing the risk of electric shock and equipment damage. The equipment grounding system typically consists of metal conduits, metal enclosures, and a dedicated equipment grounding conductor, often green or bare copper, that runs along with the circuit conductors. According to the National Electrical Code, the neutral conductor and the equipment grounding conductor must be kept separate except at the service entrance or the source of a separately derived system such as a generator or a transformer. This separation is crucial for preventing unwanted current from flowing through the equipment grounding system, which could create a shock hazard or interfere with the operation of sensitive electronic equipment. Now let's examine the implications of connecting the neutral wire to a 4-pole automatic transfer switch. An automatic transfer switch is used to automatically switch a load from a normal power source, such as the utility grid, to an alternate power source, such as a generator, in the event of a power outage. A 4-pole automatic transfer switch has 4 sets of contacts, one for each of the 3-phase conductors and one for the neutral conductor. If you connect the neutral wire to one of the poles of a 4-pole automatic transfer switch, you are effectively connecting the neutral conductor to the equipment grounding system through the transfer switch. This can create a dangerous situation during a generator transfer. When the generator is running and the automatic transfer switch is in the generator position, the neutral conductor from the generator is connected to the equipment grounding system through the automatic transfer switch. This means that any current flowing through the neutral conductor will also flow through the equipment grounding system. If there is a fault in the system, such as a ground fault, the fault current will flow through the equipment grounding system, but it may also flow through the neutral conductor and back to the generator. This can cause the generator to become overloaded and potentially damaged. Furthermore, if the equipment grounding system is not properly bonded to the neutral at the generator, the voltage in the equipment grounding system can rise to dangerous levels, creating a shock hazard for anyone who comes into contact with grounded metal surfaces. To avoid these hazards, the National Electrical Code requires that the neutral conductor be isolated from the equipment grounding system in an automatic transfer switch installation. This is typically accomplished by using a 3-pole automatic transfer switch, which only switches the 3-phase conductors and leaves the neutral conductor connected directly to the ground busbar in the panel board. The neutral conductor is then bonded to the equipment grounding system at the source of the power, such as the transformer or the generator, through a separate neutral bonding jumper. This arrangement ensures that the neutral conductor and the equipment grounding system are properly separated, preventing unwanted current from flowing through the equipment grounding system and minimizing the risk of electric shock and equipment damage. In your specific case, since you have a 480-volt Y-connected system and you are using an automatic transfer switch to switch between the transformer and a generator, you should definitely use a 3-pole automatic transfer switch. The fourth wire, the neutral, should not be connected to the automatic transfer switch. Instead, it should be connected directly to the ground busbar in each panel board through a separate neutral bonding jumper. This will ensure that your system is in compliance with the National Electrical Code and that it is safe for personnel and equipment. In summary, the neutral wire in a Y-connected system is essential for carrying unbalanced current and providing a reference point for voltage. The equipment grounding system is crucial for providing a low impedance path for fault current to return to the source. The neutral conductor and the equipment grounding conductor must be kept separate except at the service entrance or the source of a separately derived system. Connecting the neutral wire to a 4-pole automatic transfer switch can create a dangerous situation during a generator transfer. To avoid these hazards, you should use a 3-pole automatic transfer switch and connect the neutral conductor directly to the ground busbar in each panel board through a separate neutral bonding jumper. Always consult with a qualified electrical engineer or electrician to ensure that your electrical system is properly designed and installed and that it is in compliance with all applicable codes and regulations. Safety should always be the top priority when working with electrical systems. Now let's consider some additional details regarding the proper grounding and bonding techniques in your system. Grounding refers to connecting a circuit or equipment to the earth, while bonding refers to connecting different metallic parts of the electrical system together to create a continuous low impedance path for fault current. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. One important concept is the difference between the grounding electrode conductor and the equipment grounding conductor. The grounding electrode conductor connects the grounded conductor, typically the neutral, to the grounding electrode system, such as a ground rod or a metal water pipe. The equipment grounding conductor, on the other hand, connects the non-current carrying metal parts of equipment, such as enclosures and conduits, to the grounding busbar in the panel board. The equipment grounding conductor provides a path for fault current to return to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. Proper bonding is essential to ensure that all metal parts of the electrical system are at the same potential. This minimizes the risk of electric shock by preventing voltage differences between different metal surfaces. Bonding is typically accomplished by using bonding jumpers to connect metal conduits, metal enclosures, and other metal parts to the grounding busbar. The size of the bonding jumpers must be sufficient to carry the available fault current. Another important consideration is the location of the neutral bonding jumper. As mentioned earlier, the neutral conductor should be bonded to the equipment grounding system only at the service entrance or the source of a separately derived system. This is to prevent unwanted current from flowing through the equipment grounding system. In your case, the neutral bonding jumper should be located at the transformer, where the neutral conductor is connected to the grounding electrode system. In each panel board, The neutral conductor should be isolated from the equipment grounding system. This means that the neutral busbar and the ground busbar should be separate and not connected together. The only connection between the neutral and the ground should be at the transformer. When installing an automatic transfer switch, it is crucial to follow the manufacturer's instructions and the National Electrical Code requirements. The automatic transfer switch should be properly grounded and bonded to ensure that it is safe and reliable. The control wiring for the automatic transfer switch should also be properly installed and protected. In addition to using a 3-pole automatic transfer switch, you should also ensure that the automatic transfer switch is rated for the available fault current at the installation location. The available fault current is the maximum amount of current that could flow in the event of a short circuit. The automatic transfer switch must be able to withstand this current without failing. If the automatic transfer switch is not rated for the available fault current, it could be damaged or destroyed in the event of a short circuit, potentially creating a fire hazard. To determine the available fault current, you can perform a fault current study. This study involves analyzing the electrical system to determine the maximum amount of current that could flow at various points in the system. The results of the fault current study can be used to select appropriately rated electrical equipment, including the automatic transfer switch. Another important aspect of electrical safety is arc flash protection. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit in the air. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, it is important to implement appropriate safety measures, such as wearing personal protective equipment, using insulated tools, and following safe work practices. The National Electrical Code includes requirements for arc flash hazard assessment and mitigation in Article 110, 16 and 16. In summary, proper grounding and bonding are essential for electrical safety. The neutral conductor and the equipment grounding conductor must be kept separate except at the service entrance or the source of a separately derived system. The neutral bonding jumper should be located at the transformer, where the neutral conductor is connected to the grounding electrode system. In each panel board, the neutral conductor should be isolated from the equipment grounding system. When installing an automatic transfer switch, it is crucial to follow the manufacturer's instructions and the National Electrical Code requirements. The automatic transfer switch should be properly grounded and bonded and rated for the available fault current. Arc flash protection is also an important consideration for electrical safety. Always consult with a qualified electrical engineer or electrician to ensure that your electrical system is properly designed, installed, and maintained. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. If you are not comfortable working with electricity, it is best to leave it to the professionals. Let's explore the practical implications of these concepts in your plant's electrical system. First, consider the grounding electrode system. This system should consist of one or more grounding electrodes that are effectively connected to the earth. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes, also known as UFA grounds. The grounding electrode system should be installed in accordance with the National Electrical Code requirements and should be regularly inspected to ensure that it is in good condition. Next, consider the equipment grounding conductors. These conductors should be sized in accordance with the National Electrical Code Table 250.122 and should be properly connected to the grounding busbar in each panel board. The equipment grounding conductor should be run along with the circuit conductors and should be securely fastened to all metal parts of the electrical system. Now, let's discuss the automatic transfer switch installation in more detail. When installing the automatic transfer switch, you should carefully follow the manufacturer's instructions and the National Electrical Code requirements. The automatic transfer switch should be mounted in a suitable enclosure and should be protected from physical damage. The wiring connections to the automatic transfer switch should be made using appropriately sized conductors and connectors. The control wiring for the automatic transfer switch should be run in a separate conduit from the power conductors and should be properly labeled. After the automatic transfer switch is installed, it should be tested to ensure that it is operating correctly. The testing should include verifying that the automatic transfer switch switches properly between the normal and alternate power sources and that the voltage and frequency are within acceptable limits. The automatic transfer switch should also be inspected regularly to ensure that it is in good condition and that all connections are tight. In addition to the technical aspects of grounding, bonding, and automatic transfer switch installation, it is also important to consider the administrative aspects of electrical safety. This includes developing and implementing a comprehensive electrical safety program that includes written procedures, training, and regular inspections. The electrical safety program should be tailored to the specific needs of your plant and should be reviewed and updated regularly. All employees who work with electricity should be properly trained in electrical safety procedures. Training should include topics such as hazard recognition, lockout-tagout procedures, and the use of personal protective equipment. Regular inspection should be conducted to identify and correct any electrical hazards. The inspection should be performed by qualified individuals who have the necessary training and experience. Finally, it is important to document all electrical work that is performed in your plant. This includes maintaining accurate records of all electrical installations, modifications, and repairs. The documentation should include detailed drawings, specifications, and test reports. The documentation should be readily available for review by qualified personnel. By following these guidelines, you can ensure that your plant's electrical system is safe, reliable, and in compliance with all applicable codes and regulations. Remember that electrical safety is a shared responsibility and that everyone in the plant should be committed to following safe work practices.